Hello, hello guys. Please let me know firstly that if you hear me. Now let's start with the differentiation with question 1. Okay, here I have explained some of the a simple example. You don't need to do a lot, and let's try it. Okay, I'm starting to write where firstly I need to say that x is variable x. Okay, so for differentiating the first function, what's the first function? This one. I'm writing tangent of x plus sqrt x bx. So after writing this, shift enter. Okay, this is the function. The other way to make it a little bit right, just slightly different, is this one. That will work as well. Do you have a problem up to now? Do you see where? Okay. So the second example I wanna write is this one. That's not so hard. Okay. Again, x x. We don't need to define every time variable x because we did here, but it's okay. I'm gonna write it. So g equal to 4 times x. This one 3, or I can write 2 star. Okay, in Python is 2 star plus x squared plus 35 differentiation of g in terms of x. Okay, so this is, I shouldn't forget to write this x equal to here, but since I defined here, that's why it worked. Okay, and I'm gonna write another example. So this time the example is this one. 2 variable functions. So x and x comma y, h equal, what was that? Y times sine x plus differentiation. Here when I said plus means inter. Next line, h in terms of x. It will be, so we have y times sine x, so it will be, y is constant here, so it will be y cos x. So it works. What if I do for y? It should be just sine x. Yeah, it's okay. Okay, let's go to another problem. Let's go another example, another question. So we've got here, it solves the polynomial or any equation or even nonlinear equation in terms of variable that we want. Okay, so it's simple. As you see, the example, it's here. So I'm gonna try this one. very fast. Solve. I don't get notification via the chat, so I wish I could hear. X squared plus 3 times x. That's enough. X. I'm solving this question. Okay, sorry. 5x plus 6. 5x plus 6. Okay. Okay, so since I defined variable x previously, so I didn't need to define solve here. It was possible to write this one. As I said that, we didn't need to this one. Let's do another example here. Okay, what's this other example? This one, x cubed plus 2x. So x cubed plus 2x. Okay. So x cubed, it's a polynomial of degree 3. So as a result, we have 3 solutions for this. Okay. This I is showing the means I, imaginary. So this means minus I square root of 2. Okay. But how could I possible to get the real solutions is actually I can add this one, algorithm simplify. So I get just the real solutions. But if I don't know that, how can I know that actually? The first and at handy for sure it's the Google, to Google solve in Sage. But the other way, writing question mark solve or solve question mark, then compiling this means shift enter. Then here you can see a lot of information, but we can do some cheating, means typing real and finding the way that we want. Okay. Okay. One of them is this one. I did with this one. Okay. Okay. Is there any question here? Now we're gonna do this ordinary differential equation. Okay. Here now the first question is this one, and actually the structure for writing and solving or seeing the solution of the differential equation, I mean simple differential equation, is this one. Because the algorithm or solving for differential equation is not complete, you can't find any complete algorithm in any software that which is able to solve every ODE. So that's why we will do numerical methods. Now, but it is possible to solve or see some simple questions. I'm gonna write this one. Okay. So for that I have this time, what was that? It's t or x. Okay, we have just x variable. X, I would like to assign for x and y equal, let's write, I call this like handle function, maybe like Math2800 y, and y is in terms of x, and the differential equation is in terms of y and x. So it was y prime equal to 2x plus y. So y prime, we know that how to write this. y prime diff y in terms of x, and I should write in y prime everything in one side of the equality. So I will write y prime minus 2x minus y. Okay. So I write minus 2 times x minus y. And sorry, I have one which is wrong. Let's call this one dE equal, and now dE solve dE in terms of y comma x. So this is the equation. From the Math 1120 and 2310, you know how to solve this question. Next week we will have some more complicated examples. So I will do the other question, and this is y prime minus tangent of x plus y. So I will write y prime minus tangent of x plus y plus 1 equals 0. Okay, this one. X is an independent variable, y is a dependent, and we got y prime minus tangent of x plus y plus 1 equals 0. So I'm assigning this differential equation to dE, and I want the differential sage math to solve this differential equation in terms of y and x. So I shift enter. So you see that solve. Now the problems is starting here. So it's written Maxima was unable to solve this ODE. Okay, there's a hint here. Maybe it says that maybe you can consider this extra arguments. Okay, let's proceed. So I would like to write dE solve. So I don't know how to use this one. I would like to know that. Okay. So dE solve, the dE and variables, extra options here. Example for contribute. Okay, this one. I'll copy this one. So you can see some explanation for here. So contribute OD is an optional argument. By default, it's turned off. And if we turn it on, we will be able to solve some other categories of differential equations. Okay, I'm gonna turn off this one. Okay. So differential equation with this argument getting more powerful. So it's possible to solve this equation. Another example of the differential equation can be like solving a differential equation numerically. Okay, so let's solve this one. And I have, it should be enter here. I have some explanations here. You can read these extra explanations here. I'll try to solve this equation. Okay. And I would like to copy this one. Sorry, guys, I'm just duplicating it. So differential equation, you can write comma 2 or another x here. y double dash plus. So this time everything is in one side of the equality. So y double dash, I don't need to put minus 2y prime here. I write plus 2y prime plus y. Again, I do copy here times plus y. Okay. So I will add x0, y0, x1, y1. Remember that, just this is y0 equal 3, y pi on 2 equal 2. So we have, so this is a differential equation with constant coefficients. It has order, it is order 2. So we will have 2 independent solutions. So we will have 2 coefficients, not constant coefficients, C1 and C2, in order to be able to have a private solution or particular solutions. These two conditions will help us to know C1 and C2. Just be careful that here we don't have y prime. In next videos, in next weeks, we will have y prime here as well. So I will add 0, x0, y0, 0, 3, comma, x1 and y1 here. Okay. So I'll add this one. 0. What was that? 3. Pi on 2. 2. This is the differential equation. So if I solve that without extra boundaries, it will give me K1, K2, or C1 or C2. Okay,